Um, I guess I'll quickly introduce myself. I'm with Contra Costa County, and I've been implementing the CalARP program in the industrial safety ordinance for about 16 years now. I started in the county in year 2000 on April Fool's Day. So I guess maybe I didn't know what I was getting myself into. Um, I have a good group with me, and we're all engineers. And there is a lot of changes to California on how we're looking at the refineries. And I'm here to share some of our experience because we've been doing a lot of the similar things I'll show you. And so I can share with you where you might look like in a year in terms of the way the programs are going. So a quick thing about Contra Costa County, we are the Coupa for the county, and so we have the normal stuff, has business plans, underground storage tank, CalARP program, all that. We also have non-Coupa program in my office, which is green business program, stormwater. We are the responding agency for Contra Costa County, so we have a full IR response team in my office, so we have the benefit of having that working with us. And then we also implement the industrial safety ordinance that I'm going to talk about. So I think you've heard a lot all morning already that PSM, risk management plan, CalARP, they're all very, very similar. The difference with the industrial safety ordinance, it was approved in 1998, and it expanded on the CalARP program by the material that it covers. So we have more regulated material, and it also have lower threshold quantity. And so we bring more material into the program. And also we have additional requirements. And these additional requirements look a lot like the new CalARP program 4 or the PSM program that's for the refineries only. City of Richmond is actually in Contra Costa County, but they're incorporated, so they're on their own as far as the entity. So in 2002, they have to adopt a similar industrial safety ordinance in order for it to apply to a Chevron Richmond refinery. So they didn't come into our program until 2002. Just a quick look. I have about 43 CalARP facilities, and out of those 43, the yellow ones, the 4 petroleum refineries and 4 chemical manufacturing facilities related to those 4 refineries are the only facility that's covered under the industrial safety ordinance. Give you a quick overview. We do have some exemptions. I'm going to talk about that in a little bit detail later on. Storage tank with non-regulated substance, they're not covered. We don't cover jump storage. We don't cover laboratories or pilot plant scale up. On utilities, we don't cover the fuel gas or natural gas that come up to the battery limit. We cover them when they're inside process unit. And we don't cover waste tanks. From a geographical representation, those are my refineries, and as you can tell, the other 4 chemical facilities are adjacent to those refineries because they help support those refineries. So they're my hydrogen plants, and they're the sulfuric acid regeneration facilities. So what do you have to do if you have to do the industrial safety ordinance? So in addition to the risk management plan, you have to submit something we call the safety plan. Inside the safety plan, you have to talk about all the prevention program 3 elements that's already required under the risk management plan. In addition to that, you have to talk about these other expanded requirements. Mike and a bunch of other people have already talked about, we require the human factors program, and under the human factors program is when we talk about the management of organizational change, because it's managing people. We also have the facility evaluate how human factors is addressed in the existing units, meaning they have to go look at how does the person interact. So what does that look like to you? So for example, are all your valves easily reachable? Do you have tall valves that only tall people can get to? I'm pretty short. So maybe you need chain valves. Also, if you have certain emergency valves that take a long time for someone to turn it close, we want you think about whether you need to have automated actuated valve for those emergency. So we look at actually what we call a response time to emergency. So if there's an emergency activation of something, how long does the operator have to respond to that emergency? For example, if your tank has an alarm and it says a high level, is it 5 hours before the tank will overview or 10 minutes before it will overview? So those are the considerations you have to take to see whether or not you need to have some kind of automated actuated valve, so you don't have to have a person go out there and shut it off because he doesn't have enough time to respond. So that's looking at existing unit with the existing conditions and the equipment. We also ask the facility to think about human factors when they do PHAs. That's the process hazard analysis to see what are other situations that they can consider for that. Mike talked about the control and how many alarms and things like that. That's in the alarm management. But there are some simpler human factors things they're not always considered, and they almost seems illogical. I've been to plants where if you look at a PFD on their monitoring screen, they will have reactor A and reactor B, left and right. But in the field, it's reactor B and reactor A. So you're like, why do we lay things out like that? You would think that people don't do that, but people do that. So the PHA, when you're doing human factors, is you're looking at all these kinds of things. Are the drawing and the control room and the way they're depicted representative of your actual equipment layout out there? So that it's very reasonable when you come up to the equipment, if the guy said, it's the one on the left, is he talking about the one on the screen or the one outside? If they're exactly the same, there'll be no confusion. Simple things like that, or having things properly labeled so that you know that you're all talking about the same valves. So you don't talk about just pump outlet. Well, which pump outlet are you talking about? But you actually label your valves, and you'll be very clear. You're only talking about V101, and there's no ambiguity about that. So that's what we ask for in the process hazard analysis. Those are the human factors considerations. We also look at procedures. To write good procedures is actually a very difficult task. And I will tell you, based on all the training that I've been to, engineers are usually tasked to write procedures because they're the one that are designing these new units. We are the worst procedure writer there are. Because we think in a technical way, and generally speaking, we don't think the way your operators do. So we think that it's perfectly reasonable that as an operator, you want to walk up 2 steps, check your pressure gauge all the time, right? Because that's what you would do as a responsible operator. In real life, that is a very unrealistic expectation. So we say that procedures should be written with humans in mind, doing the right things all the time, what you're going to ask the operator to do. So you want to have them help you write those procedures. You want to make sure that they're engaged and reviewing those procedures, and that those procedures are written in a way that is clear to the operator that has to use them, that they know what equipment you're talking about, that you're not going to put acronyms in there of what you're referencing, and you're not going to make them do math and conversions in their head while they're trying to set the gauge. So you have to make things very obvious, right? If you're going to talk about flows and your procedure is going to have flows, then your gauge better be also the same thing. If your gauges are going to be in percentages, then your procedure should be written in percentages. So you convert them into percentages for them in your procedure, so they're not trying to convert them while they're out there in the middle of doing something. Those seem very straightforward and very obvious, but you'll be surprised when you read procedures how many of them don't match up. I've been to a facility where there's 3 identical equipment, 3 different set of gauges, 1 in PSI, 1 in flow, and 1 in percentages. So the 3 equipment, even though they're identical what they do, they were represented differently, so that you can be confused depending on which equipment you're talking on, whether you're talking about percentages. So we recommend to them they convert everything to the same thing, which in this case I think PSI pressure gauges work the best for them in terms of information and how to control that particular system. We require incident investigation on the human factors to think about human factors, and then we also, and I'm going to talk a little bit more about the root causes when I come to the individual programs. Same thing with inherently safer design. So the requirement of thinking about inherently safer design happens in lots of different places. If they do new process, we're not really doing a lot of new process. There's not a whole lot of new refineries being built. But they do have to think about them when they have new PHA recommendations, if there's any inherently safer solutions that they may have. Looking at existing units and what they can do. The Chevron incident did actually impact us. CSB made some recommendation to us also about how we can do better on our regulation. So we had a couple changes that are directly resulting from that. One of them is they say we should also look at ISS when we're looking at major changes. So that's a new change that was effective in 2014, and also in the root cause analysis recommendation. Those are new changes that we're implementing since 2014. We require safety culture assessment, also process safety metrics. I'll talk a little bit more about those couple items too when I get to it. So this is where I want to show you the way that CalARP Program 4 and the Industrial Safety Ordinance actually line up pretty close. It applies to all kind of process. We have some exemptions. Program 4 exempt the labs. I call the CalARP Program 4 Program 3 Plus because when we looked at the new requirement under Program 3, it's doing essentially the same Program 3 stuff, except here and there's some extra stuff in there. So I'm calling it Program 3 Plus. This is just a normal, already required stuff within the program. One example I can give you is very simple. For under PSI, you're also always already supposed to have the health and safety information of your material. But under the Program 4, they want you to also add, I think, PEL as a listed reported thing, stuff like that. There's additional items that's in the Program 4 on the prevention program element side. So I call it 3 plus. I'm going to spend some time talking about all these different things, but as you can see, they all pretty much line up, except for a couple of things in the bottom, and I'll cover that in the end of the presentation. So the first thing I'm going to talk about is inherently safer design and the hierarchy of hazard control. Are they different or are they the same? Well, they really are the same, but differently explained. So let me explain that to you, what I mean by that. The Center for Chemical Process Safety came out with a concept book in 1996 that talk about it's important for chemical engineers to think about designing processes and equipment to keep in mind in terms of reducing risk for the operators. The best kind of risk reduction is inherent. What does that mean? It means you don't have to think about it. The hazard has been eliminated for you. So the best example of that is when you go from a oil-based paint to a water-based paint. There's no fume at all because you're now in a water-based paint. That would be more inherent. You've eliminated a hazard that you're worried with. Well, inherent is really hard to achieve for a lot of times because, for example, the refinery is not going to get rid of the inherent danger of the flammability of the material it's doing because that's a property we desire. So you're not going to get rid of that. So the next thing you can do is think about passive measures. Passive measure mean you don't have to do anything, but it's there to protect you. So one of the best examples for that, it would be like a dike. You don't have to do anything. If you spill something, it's there. It's going to contain the material. That's passive. Active is when you have something go wrong, an action has to be required. So for example, you're going to have a high-level alarm. It's going to shut down your pump. That's an active protection. Something has to happen. There has to be an action. And then the lowest type of risk reduction strategy is procedural, or we call that administrative control. You have a procedure that says thou shalt not do that, help protect you, but it's only procedural. Someone has to actually follow it and do it. So it's an administrative control. Within the 4 categories of risk reduction, they can each have 4 approaches to the design. So I'll give you an example. When I said administrative control, you can say we will not fill up this storage tank beyond 30%. Well, that's administrative control. You say I'm going to limit my inventory to that, but I have to have it in a policy. There's no other way that I can still go to 50 because nothing's stopping me, right? The procedural just says I'm going to follow it, but I'm limiting the inventory by a procedural change. If I was active, I'll have a flow control that alarms at 30%. I'll say you're at 30%. That's an active thing. Inherent and passive doesn't quite apply to that one. So if you look at this slide, I have actually the hazard control already in here because there's only one risk reduction strategy is inherent, and that's just the inherent itself. Everything else underneath that, passive, active, and procedural, what I call the reducing risk. So in 2008, the Center for Chemical Process, CCPS, came out with a second Inherently Safer Chemical book. And in it clarified the language of inherent to say that There's first order inherent safety, and that's truly inherent. And everything else is second order, or you have risk reduction strategy. And that scheme of going from inherent to something that is less inherent, passive, active, or procedural, we're calling it the hierarchy of hazard control. And you want to go to the highest hierarchy that you can whenever you can. So in terms of how the requirement compare, ours is called Inherently Safer System, and the CalARP program 4 is Hierarchy of Hazard Control. We're really looking at the same things. You have to evaluate for your existing unit, look at PHA recommendations, thinking about major changes. You have to think about these things. When you have recommendations for investigation, you have to see if you can get higher controls. Anytime you have new process. And then we have the same language, greatest extent feasible. You have to do it to the greatest extent feasible. The next item that I'm comparing for you is what we talked about already today, human factors. So in our program, we talk about human factors in a very prescriptive way to say that one way to really effectively think about human factors is to use something called latent conditions checklist. So our latent conditions checklist is on our website. It basically says that the way that you design things in terms of human-to-human interactions, human-to-machine interactions, and your general conditions can be thought about with these thought-provoking questions, and those are called latent conditions checklist. So it's looking at the environment to say, are you creating these latent conditions that already exist so that when the right ingredients come together, it will create the incident. There are other ways to identify human factors, but the CalARP program for currently doesn't give you a tool to how to do that. It just says that you have to develop a program to evaluate human factors. Both programs talk about you must have training for your employees. In the Contra Costa counties ISO program, we talk about having specialized training. So we recognize the fact that there's general training that all employees should have to be to recognize what latent conditions are. But for the people that are going to be participating in identifying these latent conditions and or training other people on the latent conditions, they need to have specialized training. Yeah. We borrowed it from an organization, and I can't remember who is it called, like chemical manufacturer. It's cited in our guidance document. So we didn't develop it on our own. Yeah. So specialized training. So for example, I talked about writing procedure. To be good procedure writers, you should go get training on how to be good procedure writer. But the rest of your employee need to recognize what a good procedure should look like, even though they may not need to have the extent of the training the actual writer need to have. They need to recognize when the procedure is not doing all the right human factors for them. So procedure is a huge piece that we're working with. In terms of hierarchy of control, the human factors, the CalARP program says that you have to have a hierarchy of control analysis when you look at human factors also. I think that's the only difference. Management of organizational change in the ISO program come under the human factors program, but in the CalARP program 4 is actually coming out of the management of change program. It's really the same difference. In our perspective, human factors talk about how people are managed, how human and human interactions are like. So we put that under human factors. Basically, what it's saying is if you're going to look at having staffing changes that might affect the way that you may have to respond, both in a normal operation, under maintenance situation, or under an emergency situations, you must be able to ascertain that you have all the resources to do the things that you need to do. So, for example, in a rail car unloading, you need to have 3 guys because one guy needs to go over there, one guy needs to be on top, and one guy needs to be on bottom. Then you need to spell that out that you need 3 people. But if most of the time you don't need 3 people and you're going to say, I'm only going to go down to 2 people, you have to make allowance to say, what are you going to do when you have that rail car unloading situation where you needed the third person? So that's what management of organizational change does for you, is it looks at every job and evaluate what are the resources it takes to safely carry out that job. And if you cannot do it anymore because of your change, then you cannot make that change. Or you have to make allowance for that change, meaning for those times when you do need the third person, you have to get an extra person there in order for you to perform that particular function. In this case, railcar loading. And the other important things are employees have to be consulted so they know that what are all the jobs that they do so that they can be accounted for. The main difference with the CalARP program 4 is actually went a little bit further on the staffing change, because we are looking at organizational structure and staffing change, whereas CalARP program 4 actually talking about experience level and increasing responsibilities, which is a little bit more than what currently ISO is asking for. I agree with Mike that safety culture assessment is probably one of the most gray area that we do, and probably for me, an engineer, this is a topic that is somewhat uncomfortable because there's not a true science to looking at safety culture. Other than we've read up a lot about it, and from my personal experience, I can tell you safety culture can change rapidly if you are committed to the change. We saw it happen in some of our facility, but it takes a very much a coordinated effort and management commitment to see the change in your culture. However, we do think that having the right culture is really the cornerstone of any process safety management program, because you have to have the commitment at every level that safety is priority one in order for you to perform well. But how do we do that? For us, we say you have 1 year to comply. You have to do your assessment. After that 1 year, we came out with a guidance document. You must do it every 5 years. And you can use different ways to do that. You can do a written survey, and the most publicly available one would be the Baker panel survey that happened at the BP Texas incident. That survey is publicly available, and you can use that. You can do interviews. You can do observations. Someone can go and observe their other employee doing work. Or you can do focus group. That would be, you take smaller groups of people and you talk about the culture and the topic that you want to improve upon. The critical thing about doing safety culture assessment, I think, is you have to know what you're going to judge yourself in terms of performance. So for us, we're asking for assessing your management commitment and leadership, individual performance and accountability, peer-to-peer accountability, meaning I might behave differently when someone is watching me versus when I'm all by myself. So we have different behavior where you're either in a group, so that's a group dynamic, and there's also an individual dynamic on how I behave when no one's watching me. The what? Yes. So you want to assess both, individually, my commitment to safety, and also when I'm in the group. Am I going to behave differently because of the group effect? And then also you're going to judge your overall safety program. That's the program, the prevention program elements. How well is the company doing on that? We require all the companies to have written report. And from our experiences, and I think we suggested the interim assessment of corrective action within three years for the CalARP program side based on our experience. That is, when you do the assessment, you might identify a bunch of things that people are saying that the culture is not where it should be. But given that information, what can you develop as recommendation to correct that? It's a very tough job. So maybe everybody's saying, yeah, we understand that we're not getting that. I'm not getting my managers to commit, or at least the management might tell me they're very committed, but the workforce don't see that same level of commitment. So how do you change that? Well, I think that is really the big question. We can assess and say we're not there. How do you get there? So I think one way to do that is to have a recommendation that you can work on but do the interim assessment on those corrective actions to see are you heading in the right direction instead of waiting 5 years to resurvey or reassess to then decide if you need to make any correction to that. So I think that's an actual improvement on the CalARP Program 4 side. That's based on our experience. Another important thing that the ordinance does is it asks for the companies to report on process safety and performance indicator. And there's really two major differences. One is you can have leading indicator and lagging indicator. And actually some indicator can be both. So when I say a leading indicator, what am I talking about? These are indicators that can forecast something. So you might say a leading indicator could be how many times am I late in performing my PM? So it's staying ahead of something. Nothing happened yet. I know I'm supposed to do my PM. So that's a leading indicator. If I don't do those PMs at all, I may have machinery that break down, right? But that gives me a heads up. A lagging indicator are actually the things that we traditionally have measured a lot. That might be your incident rate, how many accidents did I actually have? Your OSHA recordable is a lagging indicator because things has already happened. So those are lagging indicators. And we have probably more lagging indicators than we do meaningful leading indicators, but we're hoping to develop more of those. So currently, we require these 4 that I have listed there to be what I call common, meaning every facility that's under the Industrial Safety Ordinance have to compile those and report those to us, and we put them in our annual report and post those. And in many ways, they are lagging in nature, except the past due inspection, it could be more like a leading indicator. This requirement is actually a new requirement. So we started collecting these in June 30th of last year. We've had the site collect site-specific performance indicator now for probably 5-6 years, but those are not reported. So each site can have their own indicator that they're tracking, meaning based on where they think their program needs the most work, they're going to develop indicators in that area. So for example, they might think that we have MOC that are not being discovered as MOC. So they might be auditing the MOC program to see what is missing. Basically, you go search in your PM database to see if there were things that should have been MOC that was not MOC. That would be a leading indicator to see how well is your MOC program actually performing. But those are site-specific indicators, and each site have their own sort of a leading indicator that they're using to help improve their prevention programs. So those are the same ones that are on the CalARP side in terms of what is being asked for. The one additional item that is on the CalARP Program 4 side is temporary piping repairs and a count of that. Another new requirement of Program 4 is what we call the safeguard protection analysis. This came as a result of the CSB recommendation. And basically, if you want to think of it as an additional assessment after a process hazard analysis has been performed. So in your PHA, you're looking at your scenarios to see if you have any situation where you may have high consequence event. Once you determine that you have high consequence event, you have to assess whether or not you have sufficient safeguard to prevent those high consequence events from happening. A lot of that PHA requirement currently is it's a semi-qualitative assessment, right? We use our risk matrix to determine based on the frequency and the consequence of the event to see whether or not you're sufficiently adequate in your safeguard. Well, the safeguard protection analysis is actually for those high consequence events, and for us, it would be major chemical accidental release. It's defined in the ISO. Under Program 4 is major incident. It's also defined under Program 4. They're kind of similar, basically big events. For those scenarios that have the consequence to cause these big events, do you have sufficient safeguard? And rather having it be just using the risk matrix to determine that you're sufficiently protected, we're asking for a more semi-quantitative analysis, which is the layer protection analysis. And as Michael mentioned, the quality of input highly dictate the quality of the output from your assessment. But if you want to think about layer protection analysis or LOPA analysis, it's actually like a simple math for quantitative risk assessment. So if you really want to do math, you do a QRA where you're actually multiplying all these things and you have all these decimals, right? When you do a LOPA analysis or layer protection analysis, you're actually only looking at the magnitude, the orders of magnitude. So rather than multiplying all the numbers and carrying all the numerics, you're only looking at the order of magnitude, -1, -2, -3. And so in our engineering world, it's a simpler math. But it's a math. Currently, our requirement is that the facility needs to have completed all the safeguard protection analysis by June 30th, 2019. So we gave the facility basically 5 years to do this because we added this in 2015. We say that you can do this in a standalone or inside the PHA. You can use the PHA to identify all your scenarios and then do the LOPA to assess all these situations in a standalone LOPA analysis, or it can be rolled into your PHA team. Basically, there's an advantages and disadvantage to that. PHA, a lot of times you have good discussions to talk about the scenarios, and LOPA, a lot of it is just really math. So you may not need as many of the people in the room to conduct your LOPA as you do your PHA. It's also once in every 5 years, and you do require a written report to support the LOPA analysis. So inside the industrial safety ordinance, we didn't really spell out as much detail as what needs to be required in the written report. The CalARP Program 4 actually spells out in a little bit more detail what needs to be in the report, which is identifying your initiating event, which is your scenario, and what started your scenario. It talks about risk reduction strategies, and I'm sorry for using acronyms, but IPL is your independent protection layer, which is, everything has to be independent. So if you have, so just give you a quick example. So if you have one instrumentation signal coming into your control room that controls your level and your shutdown, you can't say you have two protection, because sometimes in PHA you say, oh, you have a level alarm and you have a shutdown. Because they're using the same signal, that's really one. You have only one protection. But if you have two independent signal coming in, then you can say one is a level and then one is a shutdown. So it gives you 2 credits. So that's what the IPL stands for. It had to be independent protection for you. In order for you to claim protection credits under LOPA rules, you have to have certain maintenance and testing protocol that goes along with that. And depending on which protection layer and level of protection you want to claim, there's maintenance that goes along with how frequently those have to be tested and how they should be tested and maintained. So I have gone through all these common elements and talked about them. So there's 2 that are not common. For us, we also have something called the security vulnerability assessment. It actually came in right after the Twin Tower event. But currently, we actually don't do SVA for any site that is under MARSEC. So all our refineries under MARSEC already. So we don't ask for their SVA because another agency is actually reviewing their security plan. So we only look at any other facility that don't have another agency looking at them. We still want them to assess really under PHA how are their security addressed. The CalARP Program 4 have one additional element that is not spelled out in Industrial Safety Ordinance, even though I believe we cover it under normal mechanical integrity program already, which is the damage mechanism review. And just to give you a quick feel for what that is like, Mike Doring talked about going to the API classes, and they talk about the damage mechanisms. It's a well-known document that API says that at different conditions of these varying units, there's all these things that you watch out for. What the CalARP Program 4 now specifies is that these damage mechanisms has to be identified. They have to be put out, in the report. They have to talk about what the mechanical integrity program is doing to address them in terms of inspection and testing, or in the engineering of it, if they're doing something to mitigate those corrosion mechanism, it could be changing the piping, changing the condition. So there's different ways you can do that. You can limit the way the operation runs. So you can say, in order for that mechanism to happen, I have to be in these kind of temperature range. So you can have an administrative control to say, we will not, have these reactors exposed to that kind of temperature range, and therefore I'm not seeing that kind of corrosion mechanism happen. That's one way. Another way you can say, yep, I understand that I am in these range and I will see these kind of corrosion thing happen. So I'm going to test for them more frequently. And this is my inspection and testing program. I have to look for these, and the way to look for these specific things is this way. So that's what your MI program has to spell out based on what is identified in the damage mechanism review. And that's how you're addressing that. So it's a little bit more clearly spelled out in the CalARP program 4, whereas in the ISO program is within the MI umbrella. So just to share a little bit with you guys what we've been doing. Our audit duration goes from 1 day to 4 to 5 weeks. So our 1 day audit will be for a program 1 facility. All our program 3 facility were there for 3 weeks, and the ISO facility were there 4 to 5 weeks. And 1 to 5 engineers. 1 engineer for program 1, 2 engineers for program 2, 4 engineers for program 3, and 5 engineers for our ISO facilities. So it is a lot of effort to go to an ISO facility to look at their how well they're implementing the program. There's 2 new things that we're doing this year that I think are very good, and it's going to help us uncover a lot of things. First is we do a PNID verification. When we go on site, we look at specific PNIDs, and we pick out the ones that we correspond to some of the MOC that we're looking at. So that's where we think that it's been most helpful, is our MOC review and the PNID review is now coordinated. So we're looking for where they've made some changes, and then we're asking for those PNID, and we're actually going out to the field and we're walking them down to make sure that the PNID is representative of the field conditions, to make sure that they match. Once we do that, we look at the operating procedure. And we do an operating procedure walk down to see if those things are changed to match what the new changes are. If they don't have good candidate for us to look at, that's out of MOC, we pick out PNID out of PHAs. Look at PHAs and pick out the PNIDs from that. And then we also select procedure walk down from that. Now, the procedure walk down, we think, has been really good for us because it gives us an opportunity to do our interview in the setting of the operator. So we've always done operator interviews, but we used to ask them to come to where we are in the basically a room, and we're all there, and they have to come up to see us. So I think it's kind of intimidating that they have to leave their environment and come into usually the admin building. That's where we're sitting to come talk to us. So we think that actually doing the operating procedure walk down with them, we're going out to them, and then we're going to go out to their environment in their unit talking about the procedures with them. So we're walking through the procedure steps to make sure that these are indeed the things that they're going to do. Now, what we found interesting is they're more open with us, and also they see things that sometimes they don't even realize themselves. So I walked out with an experienced operator, and he's telling me, oh, we do this and do that. I say, oh, what about these 3 things? He looked at that. We don't ever do that. I say, then why don't you change your procedure? He goes, I don't know that. I never realized that we say that. That equipment has been out of here already for 10 years. He's just never realized it. Well, he's experienced, right? He don't always read his procedure. So he didn't even know that the procedure has been outdated. So I guess what I'm trying to say is, it's not that sometimes they are not trying to give you a good interview. But if you were to ask him, he would say, our procedures are good. They review it and that they talk about it. And I think they do that. But until you actually are going through with the procedure with them one by one, they sometimes don't even see what they should be seeing. So I think it's been most beneficial to us doing this walk down. So there's the 3 things we learned. No matter how good an engineer I am, I cannot sit in my room and read the procedure and say that that is an accurate procedure. I don't run that unit. There's no way for me to assess that. The only way that I can assess that is from the operator that runs it day to day to tell me whether or not that procedure represents what he does. So that's something that I cannot assess. Clarity of procedure. It can be really clear to me when I read it that I know exactly what I'm supposed to do. But when I go out there, I'm looking at all these valves, I'm like, oh, I don't know which one I'm supposed to turn. So unless I put myself in that same environment, that clarity of procedure can mean very different things. So that's another advantage of being out in the field. And then the human factor side. When you look at the procedure, it's very clear. Go to this valve, turn this and that, look at the gauge and record this and that, right? When you're out there, I can tell you whether or not, can I communicate with my board operator in the room? There's a lot of places you cannot hear what you're saying. I can tell him all I want. There's no way he can hear me. So those kind of things you don't know, as an auditor, I don't know sitting in my room that that's a condition out in the field until I put myself out there. There's no radio communication in that area because there's no way anyone can hear you. I wouldn't know that until I'm out there. So that's another factor that I think that being out there is something that we're learning from these procedure walk down. And we just started doing that this year. So that's been a huge learning curve for us. We actually do our assessment using what we call a questionnaire. So we break down all the CalARP and ISO requirements and we put them in a question format and we answer them in findings columns. So give you a sense of what the ISO people have to do. We answer about 409 questions covering 32 topics. That's what we cover for them in our audit. And we identify what we call deficiencies and recommendations. Deficiencies are the ones that actually have a regulatory base to that and that they didn't meet. Recommendations are just things that we think they can improve on what they do because of what we've seen done in other places. So those are not mandatory items to fix. They are recommendations. We require them to track previous action items. And we also track the previous action item in new audits to make sure they addressed all their previous action. And we document all our audits in a written report, and those are available publicly. We also provide them to our other agencies. So EPA and CalOSHA actually gets those reports from us too. Facility have 90 days to do the action plan. I think everybody does that. So from our perspective, what I think the Industrial Safety Ordinance have done for us, it has reduced the number of major events in Contra Costa County for us. So those are what we call the MCAR, Major Chemical Accidental Releases. And our audit findings in terms of number of action items, what I call deficiency, has on the average have decreased from 73 to 23. So different graph, those are my individual facilities. You can tell that they've made a lot of improvement. There's a little bit of noise in the middle, but overall, we're coming down a lot. I don't know that we can ever get to zero. I think that because we look at so many things, it's hard to be perfect. I like to get to zero. That would be my goal. But I think overall they're doing really well. 23 is really admirable for having so many questions that we look at. And give you a sense of where these are. So I took only the CalARP and the ISO portion of my ISO people facilities and broke down to where the deficiencies are found. So right now it's almost 50-50, slightly more on the ISO side. On the inherently safer system, I think one of the biggest problem that I still find is they have a hard time making sure that when they look at a project, they're actually categorizing by both the categories and the approach. So they might tell me whether it's inherent, passive, active, or procedural, but they don't always tell me whether it's minimization, intensification, or the approaches to, so they don't always report it well. So there's some issue there. Operating procedure shows on both sides. That means on the human factor side, on the procedure, they're not doing everything that could be done. On the CalARP side, I think we're still seeing some procedure that don't have all the requirement. For example, the health and safety information is maybe still missing from some of the procedure here and there. That's what that action item would be. Safety culture assessment, one of the biggest thing is none of my facility is able to really develop what we call a milestone. So our guidance document require the facility to do the assessment, and then they have to develop recommendations. But while they're trying to improve, they have to have a milestone and develop to gauge where they're at. And I think that's where they have the hardest time to come up with something like that. So I think every facility had an action item on that. And then LCs are the latent conditions checklist, and that can be anywhere. It could be in procedures, it could be in instant investigation, it could be under the management of organizational change. But that's assessment of human factors. Um, but overall, as you can tell from my earlier graph, they're doing really well with the F23. I don't have to bore you with this, but I do want to highlight one thing that we're doing now that I think is also very good. We do what we call unannounced inspections of our facilities. And starting beginning of this year, what we do in those unannounced inspections is when we show up, which that morning we'll call them as they were coming today. When we show up, we present them with a scenario, which we go out there and operate and we say, wow, you have a leak right there. And then we watch them respond. We watch them how they assess the leak. We watch them how to call it in to their supervisor. We watch how the supervisor makes the proper notification to us or not. And then we also see how they get together and try to mitigate the situation. That has been very helpful in terms of it's really a two-way conversation. I mentioned earlier to you that my office actually does the emergency response for the county. One of the frustration that my responder feel like always is that when they get the call, there's insufficient information, and they think that the facility is not telling them things that they know. But I think when we've gone to some of the facility and you're actually out there looking at an accident release and looking at scenarios, it does take time to assess and to correctly identify what you're dealing with. And I think it's a realization that is very important from my responder's perspective to get that there's a little bit of delay to correctly identify, and then it goes through the chain of command to make sure that everything is done right for the notification call to come into us. So there is about a 15 or 20-minute delay before our pager actually goes off. So we actually time all these to see if everything is working right, And so it's been taking about 15 to 20 minutes before our pager goes off from when we tell them there's a release. And so I think it's been a very good educational experience for us to do this. Our next phase of this will be to do more of the actual exercises, so maybe some actual putting on suiting up and all of that. Because right now we don't do the suiting up part of it. That's it. Any questions? 2000. Yes. There was a period of time where there was a lot. I mean, you saw those really high numbers in the 90s and early. Yeah.